Today we're going to discuss how to build a model that is able to predict whether a person has a disease or not based on given inputs. This slide represents values that can be used in order to predict whether a person has a disease or not. Values like glucose, cholesterol, and so on can all be used in order to predict our goal. Note that the disease column does not have binary values like disease or no disease. It has many categories, which is not our task. Our task is binary classification, predicting whether a person has a disease or not. These columns are known as the features, and these features can be used in order to predict what is known as the label, which is the disease. So how do we start? We start by asking some simple questions like, are all features related to our target? And to answer this question, no. Feature selection needs to be done in order to figure out which features are highly correlated to the disease. So which features can be used in order to predict if a person has a disease or not. The second question would be, is our target set to our task's definition? And as seen, the disease values were not simply binary values. So we actually have to convert these labels to zeros and ones. Now the last question would be, what model would be best for the classification task? And to answer this, we just need to try and try and try. There's no dictionary for this one. We start by observing the correlation matrix. The correlation matrix gives us values in order to indicate that this feature is related with that extent to the disease. We choose the highest correlated features, which are the mean corpuscular volume, the red blood cells, and the white blood cells. We attempt 3 trials, one involving the 3 features, one involving the highest 2 correlated features, and the last one involving just the highest correlated feature, which is the mean corpuscular volume in this case. We observe the one that leads to the best accuracy, the disease values to binary values. This can be done by simply adding a condition of not equal healthy. So if the value is not equal to healthy, convert it to 1, that it has a disease, and if it is equal to healthy, convert it to 0, that it has no disease. Now the model that's chosen is the logistic regression model. This was done after many trials because the logistic regression was found to obtain the highest accuracy when compared to SVM and the random forest. Logistic regression uses a sigmoid function in order to place a threshold separating the two classes. If the final value computed was found to be above that threshold, then it would predict that the person has a disease and it's of class 1. Otherwise, if it was below the threshold, it would be predicted that the person has no disease and it's of class 0. It's important to note that the scikit-learn library was used to import the logistic regression model. Pandas library was used, and same as the NumPy library. Now for the first 2 trials, accuracy was relatively low compared to when using the highest correlated feature alone. Using 2 features, it obtained an accuracy of 89.1%, which was higher than when the 3 features were used. Best results were obtained when using the highest correlated feature alone, and this obtained an accuracy of 94.4%.